Let me offer my thanks again to all of you for being here. This summit is really your summit, and I really appreciate all your presence. But I come before you in a very difficult and grave situation. Right before me, you heard some of the luminaries and the thought leaders of our nation. Each one of them, in their own way, has changed the world. And right ahead of me, there's lunch waiting for you. And in between, you have me. As they say, there is no free lunch. But let us take a walk to the past. I don't know how many of you recognize this. This is a punch card that was used till the 1970s to enter data into computers. And this is what we have today. Smartphones. We went from here to here in 30 years. And the whole information revolution, from transistors to integrated circuits to fiber optic and wireless communication to the internet. It all happened out here in the United States. We didn't make better and better punch cards. We invented the future and enabled the rest of the world. But we have been doing this for the last century. The Wright brothers invented the airplane, and as you heard from the secretary, we made sure we manufactured them here and then enabled mobility for the rest of the world. Norman Borlaug created the green revolution for food and saved billions of people from famine. I stand here because of Borlaug's green revolution. Jonas Salk discovered the polio vaccination, and we have almost eradicated polio from Earth. And Nikola Tesla and Westinghouse together created the first AC electricity grid right here, which other nations then adopted, which helped them modernize. I can go on and on, but here's the point. In the history of humankind, the 20th century will be remembered as the American century, because it was here that we used the greatest renewable resource, our ingenuity, to create new technologies based on science and engineering, to create new businesses based on entrepreneurship, and exported all these technologies to change the world. That's the legacy we have. With that legacy in mind, let us now look ahead to the 21st century. I believe, and many of the past speakers believe as well, that energy offers both the biggest challenges and the opportunities. Let me explain. When you go to a gas station today, you pay about $3.50 to $4 a gallon. But do you know how much we pay as a nation? $1 billion a day. $1 billion a day, because we import roughly half the oil that we use. This is not only a massive drain on our economy, it is a national security challenge. We simply cannot leave behind this legacy for our children and grandchildren. But we are not the only ones. Other nations, developed and growing, Germany, India, China, Japan, they're all oil importers. And they all want to get out of the stranglehold of imported petroleum. And that offers the biggest economic opportunity of our lifetime. There are 7 billion people in the world today. And by the end of this century, we will have roughly 10 billion people. And as these people come into this world, they want to have better lives than their parents did. As they should. But they will also need more energy than their parents needed. If we don't change the way we use energy, we will have an environmental catastrophe on our hands. Every nation wants to grow in a sustainable way, but the technologies needed that are affordable and sustainable do not all exist today. And that, my friends, offers the biggest economic opportunity of our lifetime. But make no mistake, there is a global race going on, and we must act now. If we can seize this opportunity, we will ensure the national security, the economic security, and the environmental security for our children and grandchildren. That is why we are here in ARPA-E, to invent the future. So let me tell you the ARPA-E story. Let us start. This is the ARPA-E story, the people. So let me start with transportation. We all know that we use biofuels. We can make biofuels from plants that use photosynthesis to take the energy from sunlight and store it into chemical bonds. What is not often appreciated is that these plants, corn, algae, sugarcane, switchgrass, the process of photosynthesis is less than 1% efficient, which is why you need a lot of land and you need water, which makes it expensive. And we need to do research to reduce the cost of biofuels. But if you step back for a moment, you realize that none of these plants were ever designed for energy. So we asked the question, could we truly engineer plants to directly make oil? And if so, what would they look like? So let me tell you the story of Gary Peter and his team at University of Florida. They're taking loblolly pine trees, which grow widely in the southeast, and genetically engineering them to dramatically increase the production of terpenes. Terpenes is a gasoline-like biofuel by a factor of 6 at a cost of less than $3 a gallon. Just imagine, if they're successful, you would have an area of the size of Washington, D.C. produce 20 million barrels of oil per year. That is inventing the future. But they're not the only ones. There's a team at Lawrence Berkeley National Lab which is doing something intriguing. We all know that algae can produce oil. But the challenge with algae is that they don't grow very fast. So what this team is doing is to take the metabolic pathway that produces oil in algae, only the metabolic pathway, and inserting that into a plant like tobacco that grows fast and on bad soil. Just imagine, if they're successful, you would have big oil and big tobacco come together and save the world. You just can't get better than that. But we also ask the question, do we really need plants to make oil? After all, they're less than 1% efficient. Could we use biology in a new way that is 10 times more efficient to make oil? And so 2 years ago, we created an entirely new approach. And this is how it works. It's called electrofuels. You take non-photosynthetic microbes, and if you can genetically program them the right way, They will eat carbon dioxide on one hand, or hydrogen and electricity directly on the other hand, and if you program them correctly, it'll combine them to make oil. That's the idea. And people thought, this is impossible. This is science fiction. He said, why not? Let's give it a try. So let me tell you the story of Mike Lynch and his team at OPX Biotechnologies. They did exactly that. They programmed the bug to take carbon dioxide and hydrogen to make oil. And at last year's summit, I showed you a tiny vial of the first electrofuel they had produced. And today, this is what they're making. Now, if they keep up the trajectory and grow and scale, they will create an industry that never existed today before. And what is important to note is the feedstock. The carbon dioxide and hydrogen can come from natural gas. And by the way, we are the largest producers of natural gas in the world. Just imagine, if they are successful, they will invent the future of transportation fuels by making it domestically right out here. Another option, our job at ARPA-E is to create options. Another option is the use of natural gas. And just last week, the President, on our behalf, announced a new program on the use of natural gas for light-duty vehicles so that you can refill it at home, cost-effectively. Another option, as you heard, is electrification. And it all comes down to the battery. If you were to travel today from Washington, D.C. to New York City, that battery pack is going to cost you about $30,000. Just the battery pack, $30,000. Most American families cannot afford that. So we set out a challenge for the research community. Invent that battery that will enable electric cars to have a range and cost that is comparable with gasoline-based cars so that you can sell electric cars without subsidies. Now that is sustainable business, and that battery did not exist. So let me tell you now the story of NVIA, of a startup company. What they have done is the following. They took up this challenge, and they have now created, they announced yesterday, the world record in energy density of a rechargeable lithium-ion battery. A world record of 400 watt-hour per kilogram, which is double the energy density of today's lithium-ion batteries. Now, if they're successful in scaling it and manufacturing, and if you were to use it today, it'll cut the battery cost by half. And they're working hard to reduce the cost even more. But they're not the only ones. There's a startup company called Polyplus that is making a rechargeable lithium air battery. Why lithium air? Because you can go for even higher energy density. They're shooting for higher than 500 watt-hours per kilogram. Just imagine, if they're successful, they will invent the future for electric transportation, not just for the United States, but the whole world. That's what they're trying to do. So if you were to electrify our transportation, the electricity has to be affordable and sustainable. Most of electricity comes from coal today. And we have the largest reserves of coal in the world, and we ought to be able to use it in a sustainable way. And that means you've got to capture the carbon dioxide that comes out from burning coal. Today, the cost of carbon capture from a coal-fired power plant is about $70 to $80 a ton. And that is just too expensive. Why? Because the price of CO2 that is set by enhanced oil recovery for domestic oil production is at roughly $35 a ton. The cost is 70, the price is 35. This is business 101. When the cost is higher than the price, it's a non-starter for business. So we set out a challenge for the scientific community. Invent new technologies to bring down the cost of carbon capture to $25 a ton, so that it becomes a business opportunity. So why is it $70 to $80 a ton today? Because the way we capture carbon today is we use a chemical reagent to absorb the carbon dioxide, then we got to heat it to about 150 degrees Celsius to release and compress the CO2. But you and I are capturing carbon dioxide from our cells, transporting it to our lungs, and exhaling it. We're doing it as we speak. We don't have to heat ourselves to 150 degrees Celsius. Surely there's a better way. Well, that is exactly what the team at Codexis is trying. It turns out that you and I have an enzyme called carbonic anhydrase that captures the carbon dioxide and speeds up the reaction. So what Codexis is trying to do is to use directed genetic evolution to ruggedize this enzyme, make it more efficient, make it more robust, so that it can survive and operate at the exhaust conditions, the harsh exhaust conditions of a coal-fired power plant. Just imagine, if they're successful, they will invent the future of carbon capture and clean coal. Other ways of producing electricity in a long-term sustainable way are nuclear, solar, and wind. Nuclear provides base load electricity, as you heard. But solar and wind produce electricity in a renewable way. And as you heard from the Secretary, the cost of producing electricity from solar and wind is coming down very quickly. And soon it'll be cost competitive with electricity from natural gas at about 5 cents a kilowatt hour. But the biggest challenge for solar and wind is that it comes on at a time that you may not need it, and when you need it, the sun or the wind may not be there. So the biggest gap is storage at the gigawatt hour level. That's what you need. So today, the best way to store electricity at that scale is to pump water up a dam. But you don't have dams everywhere in this nation. So we set out a challenge for the research community to come up with technologies, invent new technologies to do it at the first cost of $100 a kilowatt hour, because that's what it takes to pump water up a dam. So here's the story of a team at MIT and a new startup company called 24M. What they're trying to do is to combine and hybridize a lithium-ion battery with a fuel cell. They're taking the best of the chemistry of lithium-ion battery and putting it in an entirely new architecture of a flow battery, and they're shooting for $60 per kilowatt hour. Just imagine, if they're successful, they will have a modular and scalable to gigawatt hours level and affordable, not just in the United States, anywhere in the world. It'll be game-changing. They will invent the future of integrating renewable electricity that is intermittent. If you want to make it on demand, that's what you would need. Talking about the grid, let me frame the challenge for you. The grid is extremely important. Our whole lives depend on electricity. But let me frame the challenge. You have about $1 trillion of assets today on our grid. $1 trillion. It is massive. But it is aging. It is getting old. We cannot leave this legacy for our children and grandchildren. Let me give you an example. The transformers on our grid. If you just consider that, the average age of the transformer today is 42 years old. 2 years more than its projected lifespan. That's where we are today. This is what it looks like. This is a transformer. And you need them to drop the voltage from thousands of volts to about 120 volts that comes out in a power outlet. You certainly don't want thousands of volts coming out of your power outlet. It'll fry your home, and it might fry you too. So these are the devices that are used to drop voltages. And this substation transformer weighs about 8,000 pounds. You need a crane to install it. The design is almost the same as what Tesla used 100 years ago. And we buy most of them from overseas. That's where we are. So we ask the question, could we invent the future of electrical power technology? And in last year's summit, I talked about a company called Cree that is inventing the future of solid-state transformers. But at that time, it was only a goal. Well, here it is today. The device that you see on the fingertip is a single transistor made of silicon carbide that can handle a megawatt of electrical power. A megawatt of electrical power on your fingertip. And they are now trying to increase the switching frequency to 50,000 hertz. If that happens, that 8,000 pound of transformer will come down to 100 pounds. You can fit it in a suitcase. It is lighter, cheaper, more reliable, and smarter, because you can send in signals to this transformer. But that is not all. It just so happens that we are the biggest manufacturers of silicon carbide in the world. So just imagine, if Cree is successful, they will not only invent the future of electrical power technology, we will be exporting it to the rest of the world. Let me say a little bit about efficiency. We all know that if you can use our energy and electricity efficiently, it saves money. It's just the smart thing to do. And most of the electricity that we produce goes into our buildings. And half the energy in the building goes into heating and cooling. So we ask the question, could we invent the future of cooling technology? So let me show you an example. Here's a story of a startup company based in Austin, Texas, called Sheetak. What they're doing is to build a refrigerator that has no moving parts, no compressor, no hydrofluorocarbons, and it's the size of a credit card. That's the refrigerator, because it's made out of semiconductors. They have dramatically increased the efficiency and reduced the cost of these refrigerators to the point that it is now affordable worldwide. And they have just struck a deal with a distributor in India to make small-sized miniature refrigerators, and that is affordable now, and to put them into coolers that people could use. This is what I call make locally, sell globally. But there's something more than that. They will enable people who had never had access to refrigeration ever in their lives to use the first refrigerators in their lives so that they can preserve their food and preserve their medicines. Their life will be changed forever. And that is, Sheetak is following the example of the rich American tradition of inventing out here and enabling the world. What I've just shown you are a few chapters of the ARPA-E story. Just a few chapters. This is real. It is here. There are 180 other chapters of this story that are being showcased at the summit. And I really hope you get a chance to see them. Because what you will find is the creativity, is the entrepreneurship, and the competitive spirit of the people involved. And then you will realize that the ARPA-E story is the American story. These are the Wright brothers and the Borlaugs and the Sox and the Teslas of the 21st century. They are the crown jewels of our nation. The future prosperity and security of our nation depends on them. They will compete, and if they don't succeed now, they'll come back again. That's how innovation works. And we will continue to find them and invest in them. But make no mistake, there is a global race going on. If we don't act now, many of these innovations will go overseas and get manufactured elsewhere in the world. We need to do whatever we can to make a home for these technologies right here in the United States. We must act now to do three things. Number one, markets. Create the demand for these technologies right here in the United States. Number two, manufacturing. Manufacturing. So that these technologies can be manufactured right here in the United States. And finally, number three, finance. Give our entrepreneurs access to low cost and long-term capital on the private and the public capital markets. If we can do that, we will invent these technologies out here, make it locally, and sell it globally. So when I look around this room out here, I see the whole energy ecosystem right out here. The scientists and engineers, the entrepreneurs, the investors, small and large businesses, the non-profits, the media, and the policymakers. All right here. We're all gathered out here for a reason. Because we all believe that the 21st century is our century. This is our time. This is our moment in history. Let us invent the future together. Thank you.